We know now that in the early years of the 20th century, this world was being watched closely by intelligences greater than man's.
There are stars which are billions of years older than our sun. Some of them very likely have planets, and therefore I can imagine civilizations immensely beyond the capabilities of our own.
We're not looking for little green humanoids. We all want to meet an alien. And we have the first capability in human history to find signs of life by way of gases in the atmosphere.
If you ask me, do I believe there's life in a universe that is so vast that it's hard for me to comprehend how big it is? My personal answer is yes.
Thank you all for joining us here on the last day of the Aspen Ideas Festival. I'm Garrett Graff. I'm the director of the Cyber Initiative here at the Aspen Institute, but I'm moderating today in my second hat as a journalist and historian. I wrote a book last year called UFO, the inside story of the US government's search for alien life here and out there. And I am tremendously excited today to have a panel of some remarkable experts on this subject to talk about this. I'm joined here by Dr. Jackie Faherty, who's a senior scientist at the American Museum of Natural History and studies exoplanets. Bill Nelson, who you might recognize from that video that just played, who is the administrator of NASA. Bill spent 30 years as a senator and congressman, often on the science committee, and in 1986 actually orbited the Earth 98 times aboard the space shuttle Columbia during a period when NASA was sending members of Congress to space. Unfortunately, that's a program NASA no longer does, and the trips were always round trip. So. Unfortunately, I think that there's some innovation that could happen there for NASA. And then lastly, we have Dr. Paul Sutter, who is a Barnard College astrophysicist and theoretical cosmologist. He's an author, TV host, the host also of the Ask a Spaceman podcast, and a US cultural ambassador, which I assume means when the aliens come, he has to explain Taylor Swift to
A lot. I have a lot of explaining to do.
Yep.
It'll take a while.
So I want to start with a couple of sort of big framing thoughts, and then we're going to open it up, and we're going to take this question in sort of ever greater distances, first talking about Earth, then talking about the solar system, then talking about the universe beyond. But I think one of the biggest revelations in human understanding and knowledge in the last quarter century is the increasing probability that the math is on the side of the aliens. That as late as the 1990s, we did not know that there was a single planet outside of our own solar system. And we now understand that effectively every star out there has planets, and that a large number of those planets, not necessarily a large percentage, but a large number given the size and scale and scope of the universe, fall into what scientists call the Goldilocks zone, the sort of habitable zone, not too hot, not too cold, capable of supporting water, capable of supporting oxygen, that would allow life as we recognize it. And in sort of orders of magnitude, the current estimate is about 1 sextillion habitable planets across the universe. So that is 1 billion trillion habitable planets across the universe. So you can believe that the odds of life and intelligent life are long, but do you really think here on Earth we are a 1 in sextillion chance? And that's going to be the subject of our conversation here this morning. But I want to sort of start by talking a little bit about Earth here. And this is a question that I'm going to come to Administrator Nelson first to talk about which is we have seen in the last 5 years or so, I think, an increasing public interest and increasing interest, particularly in Washington, about the question of UFOs. NASA has begun to engage in this conversation in a way that it has not traditionally done over the last 50 years or so. Of course, the U.S. government now calls these UAPs, which is an acronym for Unidentified Anomalous Phenomenon. But NASA has set up a UAP task force and has been sort of studying and thinking about this anew in recent years. And I wonder, Administrator Nelson, if you could start by just talking a little bit about what the latest thinking is about what UFOs and UAPs are and the work that NASA is doing in that space.
If we interchangeably use aliens with life, then as I said on the clip that you saw, clearly I think that there is a life out there in this cosmos that's so big, 13.8 billion years. And we have now had a series of telescopes that is trying to identify just what Garrett described. First it was the Hubble, now it's the James Webb. It's going to be the Nancy Grace Roman that is looking at a much larger swath of the sky. It is then habitable worlds in about 2040, specifically looking for a planet that could have life. If the question is about aliens here on Earth, then that's why we got into it, because most people, the favorable thought is that the Department of Defense is hiding something. So I tasked NASA to get into it from a scientific research standpoint and utilize our assets, our satellites, our spacecraft that look at Earth. And we have an extensive array of a couple of dozen climate satellites that are looking at Earth, measuring very specifically and using those to see if we pick up anything. And then just to complete what we did was we formed a group of 16 prominent scientists and had them go ahead and start looking. They don't find any evidence of aliens here on Earth, but clearly that's still a probe to be going. And we're using some of our sensors in addition to what DOD, Department of Defense, might have on picking up things. But to my knowledge, we have not found but about 2 unexplained sightings, and we see nothing beyond that.
So, and we'll come back and talk a little bit more about this later in the conversation. Jackie, one of the things that we were talking about when we were all together prepping for this was how, not that long ago, 150 years ago or so, it was actually widely assumed that there was life within our solar system. And one of the reasons that H.G. Wells's and Orson Welles's War of the Worlds was such a powerful story was that elites, in the early 1900s widely believed that there was the possibility of meaningful life on Earth, or life on Mars. And we have sort of largely ruled out at this point the possibility of large life, intelligent life within our own solar system. But I wonder if you could talk a little bit about what you might call the search for unintelligent life in our own solar system and what the status of our understanding and where our hopes might be for finding life close by.
Yeah, maybe I could start with a little poll of the audience. This can be interactive. And no judgments on your answers. I feel like maybe that's an Aspen Ideas norm. No judgments. Just a question. How many people in the audience think that there's life, intelligent life, on Mars? Okay, good. Oops, One in the back. Nope, no judgments, no judgments. Could happen, could definitely happen. Could there be life on Mars? If I had asked that question 200 years ago, probably each hand would be shooting up in the audience because we didn't have enough evidence within the solar system to know one way or the other. The same would have gone for Venus. Venus, we now know, is this hot oven that destroys everything in life as we know it now. So right now, the scientific approach with all of the missions that we've taken through the solar system is that the solar system is not amenable to life as we know it on Earth, except for on Earth, for intelligent life. But that doesn't mean you couldn't have little fish swimming around or microbial life on Europa, on my personal favorite, Enceladus. Titan might have something. There could be stuff inside, trapped under the surface on Mars. So maybe this is what some of us might be thinking about. So there's so much potential if we remove our desire to have a conversation with the other species. We haven't figured out how to talk to dolphins yet, but that might be a possibility here. But I think that that idea is still out there for the species that might exist within our own solar system. Those missions, and Bill can probably attest to this for what NASA is investing in, is super out there, with many missions that are out there to go into the solar system and discover this kind of non-intelligent, as we refer to it, life.
Bill, could you talk a little bit about how you see those missions? You know, what NASA is working on right now in those missions, and
Sure.
where you think NASA might be heading next on these missions?
Sure. The Perseverance rover on Mars, as large as a truck, is going all over the Jezero crater, which used to be a lake on Mars. And it's at the area where a river came down. And we're digging 32 cigar-shaped titanium-filled tubes. We're trying to figure out how to get them back and not break the bank right now. We have a mission that's going next year that's going to Europa. And it is this ocean world underneath icy crust. And there very likely is some kind of life down there, just as there may be where we've been digging on Mars. It might say that Mars had a civilized life in the past. We don't know. That's why we're going. And then these space telescopes, the 4 that I mentioned, as we peer further out. Does that answer your question?
Yep. Paul, where in our solar system right now do you think you are sort of most excited about the possibility of finding microbes or life in any form?
Yeah, I would say it's so fascinating. What's been so exciting over the past 10 or 20 years is the unexpected nature of the universe, which is one of the joys of being a scientist, is you always get to be surprised. And how surprising it is that the conditions that might make life possible are in the least likely places in our solar system. Like you mentioned, Europa, Enceladus, Titan. These are worlds on the outer edge of our solar system. These are worlds that are orbiting Jupiter and Saturn. They are frozen wastelands. If you look at it from the surface, if you look at Europa, if you look at it from the outside, it's just a 100-mile thick sheet of ice. But underneath that ice is a globe-spanning liquid water ocean. There is more liquid water on this little moon of Jupiter than there is on planet Earth. And we know that life, as we know it, requires liquid water. So if we want to search for life that we would recognize, we go to the liquid water. And it's not in the inner solar system. It's not on the surface of rocky planets. It's out there in the outer solar system. That's so exciting. This is so interesting because it opens up the possibilities of where life might arise in our universe.
Jackie, could you talk a little bit about the revolution in our understanding of exoplanets and sort of what they are and how we've come to be able to recognize them and understand them and begin to map them?
Yeah, so how many people in here were born after 1995? Oh my God. That is not what I was thinking was going to happen, but excellent. And everybody that was before 95, born before it? Okay, this is my crowd. Okay. So for you all that were just raising your hands, there was a portion of your life where we didn't know we had no proof that there were planets around other stars. Those of you children that raised your hands first have lived your entire lives with the knowledge, whether you knew it or not because you didn't see it, it was in your textbooks, that there were planets around other stars. It was the year 1995 that a set of astronomers, there were two teams that were working, really two major teams, that were working on detecting the wobble that a star would show if a planet was orbiting it. It's called the radial velocity method. And people just didn't think it was going to work. Everybody thought you were crazy if you were going to even attempt this method. Now it's just so commonplace what we do. But in 1995, they released a paper, two astronomers, Didier Queloz and Michel Mayor, and they won the Nobel Prize for it in 2020. And when that happened, when they found that world, it's called 51 Pegasi, it cracked open the game. Everybody started to see the potential then. All naysayers were no longer naysayers, and we became total advocates for finding planets. Now, the oddity, though, was that planet, 51 Peg B, was like nothing we had ever seen before. Because in order to find it, we needed to find it in a short term. We didn't want to have to sit and wait for a long orbit. It takes the Earth a year to go around the sun. A PhD is typically 5 years, and you really need to verify it a couple of times when you find it. So you really want periods that are fast. You want the planet to be going around fast. So all of the first planets, all of the initial planets whip around their stars, which also means they're very hot. So a lot of the initial understanding we have of planets came with hot ones. And now, I just came from a conference. I literally got off a plane last night from a conference where we were all discussing new results of studies we're making with the James Webb Space Telescope on planets around other stars right now. Now, we're really cracking the game on planets that might be rocky and have atmospheres. So in the past, whatever 1995 to now is, I can't do that now. Over 30 years? You children in here could tell me, you're all under 30. We've gone from studying these hot, crazy worlds that are whipping around their stars to worlds that might be rocky and like ours. And right now, we are working very, very hard in the astronomical community on the exoplanet side to see if we can detect any gases in the atmospheres of any of these planets that would be indicative of life that might exist on those worlds. That's the cutting, bleeding edge of where we are at right now, trying to get molecules out of atmospheres for these just barely figuring them out rocky worlds to see if they may tell us telltale signs of some sort of life that might exist on them.
And as Jackie was saying, this was a process that started off with like finding one planet here and 3 planets there, and now you have these scientists come out, Paul, with sort of single-day press conferences where they're like, we've found 20,000 new exoplanets. And
20,000's a lot.
Well, that in single days now, we're sort of like doubling the number of exoplanets we've ever seen in some of these studies. Talk to us a little bit about, these things are like really far off, and they're really small. How do we begin on Earth to try to figure out whether this exoplanet that we're sort of detecting because of a wobble in a star, hundreds or thousands of light years away, might have oxygen or water or these sort of so-called biosignatures? How does that process even work?
Yeah, this is the game. This is the challenge. It is an incredibly difficult problem to solve, but that's why astronomers are professionals and spend their entire careers devoted to solving this one kind of problem so that we can make progress. And one of the techniques we use, what we're looking for, this word you mentioned is a wonderful word, biosignatures. These are signatures of life on another world. A signature of life on Earth would be the presence of oxygen in our atmosphere. There is way too much oxygen in our atmosphere than there would be naturally. Ultraviolet radiation from the sun really likes to break apart oxygen. It has to be replenished, and it's replenished through photosynthesis. The presence of life on Earth changes the composition of our atmosphere. And so we are looking for other signatures like that on other planets. And the trick we use is that when we're looking at the wobble of a star, or as a planet crosses in front of a face of a star, if it's a lucky alignment, if we're looking at a star and the planet just happens to cross in front of it, the light from that star filters through the atmosphere of that planet and then travels tens, hundreds, thousands of light years to us. And because that light filtered through the atmosphere, any molecules in there, carbon dioxide, oxygen, all sorts of molecules, they change the signature of that light, and we can look for that signature. We've already done this. We do this all the time. The James Webb is doing it right now. We've identified all sorts of molecules. We've even identified organic compounds. We've identified even amino acids in molecular clouds. We've found these kinds of molecules, and it's by refining these searches, especially in the next generation of telescopes, that we hope to find the signature of life.
Bill, could you back up and tell us a little bit about the James Webb Space Telescope? I mean, this has been such a revolutionary tool in the way that, almost every picture from the telescope is transforming the way that we understand the universe. I wonder if you could talk a little bit about it and its significance to this search.
And it almost didn't make it because it was way over budget. Senator Kay Bailey Hutchinson is here in the audience. She was a member of the Appropriations Committee, and the person on that committee that saved the telescope since it was 20 years. I was going to say, in addition to Kay, also Barbara Mikulski was the main one. From Maryland, where the Goddard Space Flight Center is. It's this incredibly complex, when it was designed, go in the nose cone of a rocket, and the rocket that was available at the time it was designed was the French rocket, the Ariane 6. Thus, it launched from the northeast coast of South America, and it had to be folded up. But they wanted this huge, huge mirror, so they put in a bunch of little mirrors, 36 mirrors, all designed to work in harmony, and they folded, and in addition, a whole bunch of other things had to happen. So first, you had to have the perfect launch, and it was. It was perfect. Right on the money.
So perfect.
Then 344 things had to happen perfectly. Otherwise, it was Tube City. 240 of those were the folding out and rolling out of blankets, a blanket that's as thick as a human hair, that is as big as a tennis court. 5 of them separated by about that much, and that was to keep the instrument of the telescope cold from the heat and the light of the sun. And so it'd be 350 degrees Fahrenheit on one side, the sun side, and on the other side it'd be almost the same minus. And so here it is, and it's out there and it's working. And an international community is all responsible that worked with NASA. One of the main instruments from the University of Edinburgh, and an international community is all joining in of these scientists that are studying what we're discovering. And let me just tell you one discovery just recently. About 290 million years after the very beginning. And we know the very beginning was 13.8 billion years ago. And they're discovering the light and the formation of the first galaxies. So that's 13.5 billion years plus. And we're receiving that light in the infrared spectrum. And think how big that universe is. Light at 186,000 miles per second that it travels. It's been traveling 13.5 billion years. That's a pretty long distance for a country boy.
So, Paul, one of the things that the James Webb Space Telescope is showing us is that some of these galaxies started forming, so much earlier than we ever imagined, or at least knew. And to me, one of the things that really begins to indicate is, we are actually a very young civilization in a very young solar system in this incredibly old galaxy, or incredibly old universe. That, our solar system is 4.5-ish billion years old in a 13.8 billion year old universe, where some of those galaxies began to form as soon as 300 million years after the formation of the universe, after the Big Bang. So one of the things that, when I got into thinking about this and studying it in my book, that I began to sort of wrestle with is this possibility that intelligent life has come and gone before we ever began to gather out of dust. That there's the possibility that you could have had billion-year civilizations. I mean, civilizations sort of far more advanced than anything that we could possibly imagine, that have come and gone perhaps even multiple times before our solar system ever began to form. I wonder if you could talk about, and then I'm going to come back and ask Bill and Jackie sort of the same question, given all that we have begun to understand about the size and scale and scope of the universe, what do you think the chances are that intelligent life is out there? What do you think the chances are that it exists right now?
This is such a fun question, and this is the question. And we don't have an answer. So far, we have no evidence whatsoever of any life outside of the Earth. We just don't. We don't have that evidence yet. But we also know we've only just gotten started in our searches. And so we can take little threads, little pieces of information, and try to put together a story. One of those threads is that life appeared on the Earth pretty much as soon as it was possible for life to appear on the Earth. As soon as the planet cooled, as soon as our oceans formed, we see fossil evidence for life. So life appeared as soon as it could. As soon as the conditions were right, we had life on the Earth. And our Earth formed about 4.5 billion years ago. Very quickly after that, life appeared on our planet. And Bill, thank you for so eloquently painting this picture of how vast our universe is. And our universe is tremendous in every sense of the word. There are around 300 billion stars in our Milky Way galaxy alone. There are at minimum 300 billion planets in our galaxy. The largest estimates put it somewhere around a few quadrillion planets in our Milky Way galaxy. It's huge. There are approximately 2 trillion galaxies in the observable universe. Our universe is about 90 billion light years across. That's the limit of what we can see. There are about 2 trillion galaxies in that volume. There are more past that, we just can't see them.
And I just want to emphasize that number there. 90 billion light years across.
Containing 2 trillion individual galaxies, each with hundreds of billions of stars. And our universe is old. The first stars, the first galaxies appeared in our universe when it was around 300 million years old. Our own Milky Way galaxy emerged around 12 to 13 billion years ago. If life happened here, if life can happen like that in an instant, as soon as the conditions are favorable, then this is based on no science. This is just what helps me sleep at night. Then life is probably somewhat common in the universe because there are just so many chances, both in time and space and numbers, for life to arise. But this opens up a very troubling question, which is if intelligence can arise, if it can appear, and if intelligent civilizations can become so much more advanced than ours, then where are they? We've heard no radio signals. We see no artifacts. We see no modifications of stars. We see no megastructures. Yeah, we've just looked, but if life is super common, astronomers are pretty good at their job. We're able to find pretty rare things in the universe, and yet we found nothing. And so there is this apparent paradox of if life is common, if life is easy to make. If the universe likes making life, then where is everybody?
This is something called the Fermi paradox, which we'll come back and talk a little bit more about, I think, in a little bit. But Bill, let me ask you sort of the same question, just your personal gut theory of the case of intelligent life out there, and are we alone right now?
Well, it's pretty simple for me, just like I said in the clip. In a universe that is this vast, is there not the probability that life is out there? And clearly, to me, the common sense answer is yes. I ask our scientists, Mark Clampton and Dr. Zurbuchen, this question: how many other Earth-like planets with the chemical composition, with the right distance from their star, their sun, how many there could be? You said, Garrett, you said 1 billion trillion. They said to me, a trillion. And I said, 1 trillion? And they said, maybe 2 trillion. So whatever it is, it's a lot of possibility.
It's still debated amongst the exoplanet community, I can tell you that. Exactly how many. So nobody go home and write that number down and say that they said it at the Aspen Ideas panel, this is the answer, because it's still debated. My turn on this? All right, so I have several ways to answer this question, and I think it's very complicated. So I usually tell people there are 2 ways to answer the question. One is with science, and then one is with your gut. And you got some gut answers here, which is great. The science answer is we try and approach it with statistical analyses now that we're past the 1995 problem of not having detected a single planet. And now that the statistics are telling us pretty strongly that there is at least one planet around every star in our own galaxy. Now that's dependent on a lot of different factors that happen. You don't need the details, but we're gonna go with the average of 1. I mean, we're pretty solid on a large fraction. It's not hard to form planets. Let's say that. It's not hard at all to form planets. We definitely know that now. But it's an unsolved problem right now for me to give you an answer at the probability that a world emerges, survives, and can have intelligent life like our own. My gut wants to tell me sure, yes, why not? I don't want to be alone. I don't like the concept that we are the only civilization out there, but that is such a bad thing to go into answering a scientific problem with. I study atmospheres of planets beyond our own, and if I went in to my own investigations by looking at the atmospheres of these worlds with the idea embedded in my head that there was going to be life because there must be, I'm going to interpret my data incorrectly. I'm going to bias myself. So I need to, and I also encourage all of my colleagues to do this, to go in unbiased. Because while my gut might want to say yes, my scientific approach has to go with there's an equal possibility that there is and is not. And really, for all of you here, it's profound. The answer being yes or no. It is profound, unbelievably profound if we're it. Unbelievably profound. What an amazing, horribly depressing, but amazing thing if we are the outcome of the intellectual life of the universe. We, with our current political state, are the outcome. If it's the other, it's so profound because we get to join a galactic community and we can't wait to see who the alien political leaders are or whatever. Amazing. So I'm good with either answer. And I will say this again, I do not ever want to bias the scientific experiment because from the scientific side, from the sheer scientific side, as Paul laid out for you as well, there's no science. It doesn't mean there's no science, but there's also, we don't have the answer. Scientists don't have the answer for you on this at all.
Yet. We're working.
Maybe in our lifetimes it'll happen.
So I want to open it up to questions here, but want to pick up a thread that both Paul and Jackie touched on here, which is this Fermi paradox, which is this question posed by Enrico Fermi, sort of noted physicist. If you saw Oppenheimer, you know who Fermi is. Speaking in the summer of 1950 over lunch at Los Alamos with some of his colleagues, including Edward Teller, another name you probably know from Oppenheimer, and they're talking about sort of the possibility of life out there, and Fermi sort of asks this question in the middle of lunch, you know, if life is as common as we think it is, you know, where are they all? And, you know, why haven't we seen all of the signs that Paul was talking about? And why does it seem as rare? And this becomes one of the building blocks of what the scientific community now calls the search for extraterrestrial intelligence, and becomes sort of part of probably the most famous equation in this world, which is called the Drake equation, which is this equation that calculates the chance of finding other life out there. And, you know, it's a pretty simple equation of, you know, the number of planets, the percentage of those planets that are habitable, the percentage of those habitable planets that life arises, the percentage of those planets that where life arises, where it turns into intelligent life, so on and so forth. But one of the variables, and to me this is sort of the most poignant part of the Drake equation and this conversation, is just how long intelligent life actually lasts. Because one of the things that is intelligent life could arise very commonly across the universe, but that the lifespan of an intelligent civilization could be very short. And that when you look at our civilization, for instance, you know, we are a civilization that is sort of on the order of, you know, thousands or tens of thousands of years old, and, you know, which is a drop in the bucket of astronomical time. And there's a lot of reasons to think, looking out at our civilization right now, that we might not get another 1,000 years or another 10,000 years as our civilization. You know, there's some days a lot of reason to think we don't get another 100 years as an intelligent civilization. And so that sort of one of the, I think, profound parts of this could be intelligent life is very common. We are functionally alone right now. Mm-hmm. So let me open it up to questions here. We have mics on both aisles, so when I call on you, if you can wait for a mic to get to you, we'll start right here.
Thank you so much. It was an extremely interesting panel. I was wondering if each of you can comment on the discussion that's going around a lot about whether it makes sense to send signals out randomly to see what comes back. You know, I won't go into it all. You all know the story. But if each of you comment, is that a good idea or a bad idea?
Paul, let's start with you.
I think it's a bad idea in the sense of it's a waste of time. Yeah. The universe is vast, which is what gives us all these potential chances for life. It's also vast, which means we're not seen, we're not heard. Our most powerful radio broadcasts that we can possibly concoct don't even make it to Proxima Centauri, the next nearest star, before fading into the background. No one's listening. Even if they're out there, they're so far away from us that they're unlikely to hear our signal. Even if they did, there's not a lot interesting on the Earth, especially if you've seen social media. There's just not a lot interesting happening. Like, if you want resources, if you want water.
This does not sound like the official position of a cultural ambassador. You can't start off by saying there's nothing interesting here.
There's many cultural interesting, there's many unique things about the Earth. But in terms of like natural resources, if you want gold, if you want water, if you want palladium or whatever, you can just get it anywhere in the universe. You don't need to visit a planet for that. There's no danger of aliens coming to conquer us because there's nothing worth conquering here. They just want, if they want to have a chat, that chat is over thousands of light years minimum, which means that's thousands of years between call and response. This is like the slowest like text message you can possibly imagine. And you're spending millennia wondering if they're ghosting us. No, it's just the speed of light. So we have much more interesting avenues to pursue.
I want to counter just for a sec on this, because I'm with you but not with you at some level. A couple of years ago, I wrote a paper with an astrophysicist named Lisa Kaltenegger. It was called Earth as a Transiting Planet. And we actually flipped the question. Rather than us always looking out and seeing like how many worlds could we look to see if we can detect their technosignatures, we flipped the question and said, how many could detect us and our technosignature? And the result was and we used motion as well in this, because we're all in motion. You guys don't even realize it. We're getting farther away from Proxima Centauri right now. There's another star coming in. Ooh, do you know this? I'm going to tell you this. There's a star called Gliese 710. Gliese 710 is currently a couple parsecs away. It's in the it's like 15 light years away, but it's on its way. We're on its way to it, and it's on its way to us. It is going to come within a couple of light months of us. In 1 million years. All of us will be dead, even you pre-1995ers in the room. All of us will be dead, but that thing's probably carrying a solar system with it, as we've just discussed, as everything has a solar system. It's careening through our Oort cloud, the full extent of our solar system. Gliese 710, write it down. It's coming. We're going for it. The whole solar neighborhood changes. Now, when we asked this question, we took motion into account to see what are the chances that another area in our own solar neighborhood. Don't think about the vastness, yes, but think of our solar neighborhood. Like there's 3,648 stars within about 60 light years from us. Those are the ones you should think about. Should we signal any of them? And I started to feel really uncomfortable at being loud as a solar system, because Paul's right, it's unlikely they'd want to come and whatever, get us, but I don't like what we do to each other on this planet when it comes down to like, let's sail around and take over a country. That feels wrong. What if that's the galactic attitude that other civilizations might have? I can't discount that as a potential. So my preference is to just be quiet, stay in our lane, right here. I don't want to announce, not yet. Let's figure some more stuff out. Let's figure ourselves out first before we scream. Okay.
Bill.
So in the 1970s, we launched 2 Voyagers. Those 2 Voyagers are now beginning outside of this solar system into interstellar space. And the scientist that you saw in the video, Carl Sagan, helped design a plate that if it encountered any other intelligent life, that the way that they described where Earth is and what a human was like and so forth. I have tasked our scientists with thinking about utilizing artificial intelligence as a way, if we ever had an encounter in the future, and who knows? I don't know if something's going to come. These distances are so vast, as the 2 scientists here have said. Even if you could travel at the speed of light, just think how long it's going to take you. So as we venture further out into interstellar space, we're going to see if there's some way that we could have an intelligent communication.
So one of the things Carl Sagan, who you saw in those clips, most famous astronomer probably of the 20th century, he was simultaneously the most arch skeptic that UFOs visiting here represented aliens, while also being probably one of the primary drivers of the search for extraterrestrial intelligence out there. Sagan's argument, though, was sort of always more nuanced than people generally understood, which was, and Paul, you touched on this a little bit, and Jackie, you touched on this a little bit, which is we're just not that interesting of a destination for aliens. And that Sagan's argument was not that aliens didn't visit Earth, it was that no alien would be bothering to try to visit Earth, and that aliens, when they pass by, are going to be treating Earth sort of more like a rest stop on the Jersey Turnpike. That they sort of come through, his sort of calculation was every 100,000 or 200,000 years sort of just passing by on their way from one interesting place to another. And so his argument was not aliens don't visit Earth, it's that the thing that you saw out your window last Tuesday night was statistically unlikely to be the one time in these 200,000 years that an alien happened to stop by right here. So let me ask the three of you sort of a brief question that Jackie specifically is going to hate, which is, do you believe intelligent life has ever visited Earth? Not right now, not necessarily in human lifespan, but do you think there has sort of ever been intelligent visitors to Earth?
I don't know.
Paul?
As much as I would like it to be true, I don't think it's happened.
Jackie?
Are we going to count like people on Venus? Like Venus could have been habitable for 1 billion years, maybe 2 billion years. Or do you mean outside of the solar system?
No, Venetians visiting us would be...
Yeah, this is all so hard to answer. And we're drawing, all three of us are going to draw from our favorite science fiction at some level, because we don't know if this could be or couldn't be. Do I want there to have been intelligent aliens? I don't know. No, yes, maybe, not sure. I don't know. My answer is no. No, final answer, no. I don't think, no. So. No aliens, no intelligent aliens.
And thanks everyone for coming on that journey with Jackie. Let's
roller coaster.
Question right over here, and we'll try to get some quick questions and quick answers in these last 4 minutes.
Since space is big, like really big, overwhelmingly big, do you think Hitchhiker's Guide to the Galaxy is comedy or prophecy?
Paul?
Why not both?
All right. Next question over here.
Of all the thousands of people that have made what we've discovered possible, to what extent did Brian May's PhD thesis on Doppler adjustments for dust, interstellar dust, make possible what we've learned so far? And if it did, is there a possibility that calculation is excluding signals that might be informative about life?
Jackie, is this something you can...
Oh, Brian Mays as in Queen, the rock band. Yes, he is, he has an astrophysical background. I've never read any of his papers though, so I can't comment on the science in there. But it feels like you're asking about dust maybe extincting a signal. And that is, of course, a problem. Or I shouldn't say it's a problem. It's a portion of how we understand how electromagnetic signals travel through the galaxy. But if you're going to send a technosignature out, hopefully it'll be nice and strong. The major thing that happens to it isn't even the dust will really prevent it. It could. It would be that the distances are just too vast and the signal degrades.
Not going out.
Coming in?
Is it masking what might be coming in?
Oh, no. I'm going to take 2 seconds. We live inside of something called a local cavity or a local bubble. This is this crazy thing that about 10 billion years ago, a supernova went off in this area, and it cleared out the area. It happens all the time across the galaxy. We're a disk star. We're in the disk of the Milky Way, and the sun entered it about 4 million years ago. When it did, it passed this thing called the ionization extent of the local bubble, and when we did that affected things on this planet, and we see it in these ice cores that we've pulled out. You can see these higher levels of iron and manganese. Now, we're inside of the cavity now, so we're actually in a fairly underdense area. In 4 million years, that's going to change. If you want to hear more about that, ask me later. It's a whole other topic.
All right, we're going to try to get 2 more questions in. Woman right here.
In this discussion, I hear a lot of laden terms like intelligent, unintelligent, civilization, which convey a lot of human exceptionalism. And I'm wondering how that affects the paradigm of the search for other life?
Paul or Bill, do you want to?
It absolutely affects it. We know we're biasing ourselves by looking for life that looks like us. We're doing that because we know what that looks like. We know what we sound like. We know what we're made of. We know the chemicals that we use, and so we look for those signatures. There could absolutely be different kinds of life, different kinds of intelligence that would be completely unrecognizable, but that's the problem. They'd be unrecognizable. We wouldn't know it if we saw it. So by narrowing our search, by intentionally biasing ourselves, we're giving us a better chance of a real positive detection.
And we intelligent beings have the chutzpah to think that we can go out and colonize other worlds. And to be determined. But we're working on it.
All right, I'm going to go over time for 1 minute and take one final question. Up over here. Yep.
Thank you. Is it possible that through the laws of physics and how big the universe is, that it's just physically not possible for intelligent life to travel to where we are, or for us to ever travel to where they are? Could that be part of the explanation?
Yes, I think
it's possible. It's just really, really hard. Extremely hard. The universe is much bigger than we have the capacity to imagine.
Bill, how are you coming on that wormhole travel initiative that NASA needs?
No, for example, say these telescopes that are going up, that we discover a world and we think there's a civilization there. And let's say it's 1,000 light years away. Goodness gracious, we have limitation on our human bodies. How are we going to travel that far unless you're some kind of extraordinary creature that is adapted in different ways? It's going to be very difficult to do that.
To give you some very quick perspective, Bill mentioned the Voyager probes, which are currently outside the solar system. If they were headed in the direction of the next nearest star, which they're not, but if they were, they would reach that star in about 40,000 years.
And Voyager, by the way, is still communicating with us. And at the speed of light, it takes it 22 hours to reach the big dishes that receive it at Canberra, Australia.
And to me, I think this is a sort of a closing comment here. What I find so inspiring about the search for extraterrestrial intelligence is the sort of optimism and hope at the core of scientists like you all who have embarked in the last 70 years on a quest that may not have an answer in the next 100 years, 1,000 years, 10,000 years, but sort of that we are putting into place the beginning of the questions and the searches and the experiments that might yield an answer. And I think to me, at my most optimistic moments, it's a great example of why we need to take so much better care of ourselves here on this planet and the planet itself, because we are sort of protecting and unlocking all of the human knowledge that we have not yet discovered, and that sort of the generations of science and advances in our understanding of the world and universe around us that are yet to come. So with that, thank you all for coming to the Aspen Ideas Festival. Thank you, Paul, Bill, Jackie. This was just a fabulous conversation.